Hello. In conjunction with my microphone testing, as I've got some other bits to work with now, I need to make a couple of longer cables up to get to my silence box from across the other end, as far away as I can really, to do comparative tests for background noise internal to the microphones. I don't know how many people are familiar with Starquad cable, which is the best type you can use for XLR microphone leads. So I thought I'd just do a quick video showing how to make the stuff up, make cables up. In general, if you're interested in DIY audio, you need to learn to make your own cables. They are generally a lot cheaper and probably a lot better than stuff you can buy, including silly priced ones. I'm using this Damme 4-core. It's they just call it Quad microphone, XKE Quad microphone, but generally it's nicknamed Starquad because it's got 4 cores arranged as 2 opposed pairs, 2 one colour, 2 the other colour. So you've got a 4-core cable, but you wire it as 2-core plus the screen. I'll go into more detail why in a minute. The first thing you do when you're making these up is put the backshells on the cable. I'm using colour coding rings, which you can buy in packs of assorted colours, or a pack of 10 I think, so you can tell which cable is which. You can also buy coloured backshells instead as well that replace the black backshells, so you can use those as they are, or you can swap the colour coding rings on those as well, so you can use a 2-colour combination for each cable. I'll just get these ready so I can put these on. Connectors are all Neutrik. It's my preferred type. They're easy to assemble and they're very good quality, but not expensive. It's a bit stiff sometimes. Come on. Wow, that one is being a pain. There it goes. Right. So I have already checked which end's which, and I've put numbers on them. Oh, that was a cable 1. They're the 2 ends. So I'll put 2 backshells, the same colour on that one, and then the other 2 on the other cable. That's cable 2. It's a bit embarrassing if you put 2 sockets on one and 2 plugs on the other. Right. So I've got to pile all the bits at the back here for the plugs and sockets. So first thing is to strip the cable about 1 inch or so, 25mm, 25 to 30mm range. You can always trim it back a little bit afterwards if needed. Just carefully nick all the way around the cable without too much pressure, so you don't cut all the way through it and damage the insulation on the inner cables. Then flex it and stretch it, and just very gentle with a knife, and the rest of the insulation will part down to the braid. You see it partly tears, or it's very close to tear. Now this is also polyurethane insulated. It's a very high quality cable, but again it's not expensive. It's only about £1 a metre. Polyurethane is inherently elastic. It's a lot better material than PVC. The cable made using polyurethane tends to be a bit more expensive. It doesn't go brittle like PVC. PVC is naturally a hard plastic, and it's got additives, plasticizers, to make it flexible. And over time, as they evaporate or leach out into other materials, then the stuff will tend to go brittle and start cracking. And also the slightest scratch on it, once it starts to go brittle, and it will crack with flexing. That's an easy way. If we did that with PVC cable, could have put a cut in it like that. All I'd have to do is squeeze it, and the crack would go straight through to the centre and split the outer. makes it very easy to strip, but it means it's also quite easy to damage in the long term. Just take about the same amount off all of them. Right, that's the first thing. Now, ouch, those ends can be a little bit sharp, especially if you've got cuts in your fingers. Right, makes them a bit more sensitive. You should be able to push the braid back to expand it a bit. You just tease out the braid strand. Find one that's not tangled up so you can get a bit closer to the light. Just to get under some of the groups of strands and start pulling them back out of the overall bundle. The installation end of the bared part. It doesn't take long just to work around and unweave the braid. So you have a bundle of loose wires. The other way you can do this on some cables is just separate the braid close to the end of the insulation. And if it's loose enough weave, this is a very tight weave, you can pull the entire bundle of cable back through the side, an expanded slot in the side of the braid. Just make sure you don't lose any strands. I've got one odd strand there. Don't want to get that mixed up with the conductors. And see, this has also got extra string type material in it as packing for reinforcement and to keep the cable round despite the cores being not round in the bundle. Right, now that's down to the actual 4-wire quad. And as you can see, there's 2 blues and 2 whites as diagonally opposite pairs. Now, the normal twisted pair, although it's very good on average, if you have a cable crossing a pair and it happens to, say you've got a power cable that is, or something that's generating interference, or it's resting on something that's got static or AC leakage on it. If the pair in the twist happens to be that way to the interference source, both cables pick up the noise equally and it cancels out. However, if it happens to be at a part of a twist where it's edge on, one cable will pick up a signal more than the other. It doesn't cancel perfectly. With the 4-wire version, the Starquad or quad wire, because the 2 opposite conductors are connected together at both ends, as far as the magnetic field is concerned, the centre is at the dead centre of the cable. Or to look at it another way, as one part of it gets nearer, the other one gets further, so the overall effect is more or less equal all the time. It appears there's 2 to the field as if there's 2 conductors running through the same exact point, because the pair centres are in the same place in the centre of the cable. So it is that much better at cancelling interference pickup. Anyway, get on to the plug fitting. I also put the strain relief on there. I could have done that before I stripped the end, but they are split with these, so it's not too important. You can just spread the things out a little bit and put them on sideways if you need to. If you don't put it on to start with, and you don't want to thread it over the end and make a mess of the braid. It's no problem. You do it either way. And the strain reliefs and backshells are interchangeable between the plug and the socket. They're all the same, so you don't have to worry about which of those. So Let me just get the rest of these separated out. Then I'll go on to the plug fitting details, plug and socket fitting. Okay, that's those ready. Now, if you look at the position those are going to be in, they don't go into the back of them very far. In fact, they're only about level with the front of the thread, so you don't want too much wire, because you want the strain relief to be able to grip the cable. So I'm going to go for about 20mm. I've got them clear, and I got the ends trimmed, prepared. But remember, the braid that will unravel is a little bit longer, so I've got more to work with that. That is needed for the earth on pin 1. And the metalwork screen. Right, so now choose a pair, no matter which. Now they're both whites or both blues. Strip them back a little bit. And tin them. And do the other one. I think the insulation in these is polyurethane as well, which is often used on high frequency or low loss cables. It's a lot less dielectric loss than PVC as well. Obviously, making them up with normal twin screen one pair, then there's only one of each colour, two cores and screen, possibly a drain wire depending on the cable style. If it's foil rather than braid screen. So effectively, trim them and tin the ends, and you have 2 terminals and screen, just as these are, except each one's 1 wire rather than 2. But the principle is generally the same. It's just this is the 4-core, and it needs that little bit of extra preparation just to pair them up correctly. Now try and get the braid separated out into 2 bundles on either side and twist them. Try and make sure that it's neat and each bundle has wires from the correct side and they don't wrap round too much. They need 2 earths, 4 terminal tags in total in the connectors, 3 pins and the body connection. And I like to use the body connection for the little spring contact there. It's on the flat tag rather than the big pin. Just ensures the connector itself screened. Plug to socket to extend cables rather than into something that's got a metal casing where the connector body is grounded through the casing. If you're only using 2 leads, one to extend the other, then if the connector body's not ground, you're losing the screening at that point. And that's one of the great things with the XLR microphone cables. You can daisy chain them, just plug to socket. And if you want a longer cable and you've only got a short one about, or you want to make one a bit longer, you just combine them any way you want. Or, daisy chain several together to make a really long one. And just generates a nice system. That's the 4 ends prepared a bit more. Now I want to take one of those, bend it parallel to the other connections and tin it there. And that can be cut to about the same length. Now, to be honest, you don't need really, if the plugs are made properly, to insulate that braid wire, because once they're all in, let's see which number's which. One's ground, that side. 2 is positive, 3 ground. Yeah, so that is the actual arrangement they'll be going. I'll get that on it, hook in there. That's on a socket. You can see if it's all assembled properly, it doesn't twist up. It's virtually impossible for that bit of braid there to get close enough to the pins to short out. So it doesn't need to be insulated, and obviously it doesn't matter if it touches the inside of the casing, whether it's the plastic or the metal, because that other one is going to be connected to the metal contact. You could, if you wanted, just put a little bit of sleeving on that one. But as I say, I don't consider it necessary. Right, so I'll tin. Just get that white, that solder set up to hold rigid. I'm going to tin the inside of the main contacts. Just trying to get the wire and the solder both in at the same time if they're not tinned, and then ensure that the flux flows full depth on both is rather tricky, and I don't consider that a reliable method of doing it. I'd rather tin them and then reflow them on things like this. Both surfaces are tinned, still be a bit of residual flux, but just an extra tiny bit of solder, a bit of heat, and that is a sound connection. And so that pin 1 is ground, pin 2 is signal, positive, which I'm using blue for negative, white for positive. It doesn't actually matter which way around they are, as long as ideally in any one cable you get the same coding at both ends. So it keeps the phasing. Let's get a bit more fluid into that. Like that. Heat up and flow. And yes, it's very hot. Get that one into position in the third terminal. And reflow that. So that's got the 3 main terminals soldered. Now it's just a matter of taking that braid round to there. Now see how long it needs to be. I'll solder it, I'll tin it rather, tin the tag. That's another thing, if you've seen tinning the braid in advance, it's making it a lot stiffer near the pin. So again, it's making it very difficult for it to flex anywhere. Let's just run now up getting that to stay in place. What's the flow? There we go. So you can see that even if they twist a bit, there's no chance those bare wires can touch the signal wires. And that one is number 2, so I want a plug on the other end of number 2, which is that one. So that's going to be one of these. Same procedure. They're made up. Tin the pins. Now you can use a socket to hold these, because trying to hold the pins whilst you're tinning the pins or soldering the pins is a bit difficult. So it's a lot easier to use a socket as a retaining tool. I'll do that one whilst I'm at it. Right, so on this one, it's the mirror image. That's pin 1. Screen's pin 1, still rather. So the arrangement is something like that. So again, I'll put the screen in first. It's very hot still. Just reminding me. Get that, so it'll just slide into that. There we go. Oh. Yes, that bit's definitely going to sting. Right, and then that one goes into there. Just get it into position so it's resting in the first part of the solder cup, not over the edge of it. And I'm going to move the plug a little bit after it's started to flow. I'm just going to get it back in before solder starts to cool. Then the screen connection. I'm trying to keep them well kinked away from the centre to give it a bit longer path, and also keep it parallel and away from the other contacts. I don't want too much heat going back through to the cable itself in the braid. Or the braid, yeah, where the braid is in close proximity to the other wires, and risk melting the insulation anyway. A bit of solder, and probably better putting that on the inside of that contact, looking at the proximity. That's quite close to the side of the thing. I don't want to risk jamming it. Whereas the socket's got the other tag well away from the circumference of the body. The plug's got it very close in, so it's better to put the wire on top. But that's one plug. So put a socket and a plug on the other one. That happens to have the right arrangement for the plug, so I'll not use that one. Put the socket on this one. I'm trying to do with these, I mean, it's a similar technique with D plugs or whatever. Bend that so the tip of it, as it first touches, is outside the actual scoop part of the plug pin, about there. So as the solder flows, it drops right into the centre of the pin. Then by flexing the cable bit as well as it goes in, you can push it the rest of the way. Just the ground on that one, and then close them up. Okay, so plug bodies. Pips on the connector in an irregular pattern. One dead centre over the middle pin, but another one at another angle. You've got to look at the grooves in the case and see which way around they're going from the back. So that goes in that way. I get it there. And the strain leaf pushes it the rest of the way in. That's it. Then the back shell will go in and screw in. Now, whilst you're doing this, try and hold the cable and the plug end. That's it, fine. So you only turn the back shell and not twisting the cable within the plug until the strain leaf gets a really good grip as it starts to tighten, and it can't turn. So that's one. That's another plug. No, it's not, that's a socket. That's another plug. And the sockets are a bit more obvious because I've got the big lump dead centre in the bottom that locates into the face of the socket body. That should be some good cables. Well, and as I say, that's a great thing with these, you can just daisy chain them as far as you want, as long as they're decent connectors. And I got a microphone stand, a little desk stand, counterpoint arm, positioning stand, free with one of those Newa mics, and that has a microphone cable pre-threaded through it with an XLR plug and a socket, which great you'd think, except I can't remember which, if it's the plug or the socket. I think it's the socket. It's so badly made that a proper plug won't actually go into it. It just kind of jams on the lip and won't plug in. And so it's totally useless, which is a bit of a shame. Anyway, that's the cables made up, and I'll now carry on with the audio tests on these microphones. Direct noise tests in the Sarts box in another video. Thanks for watching, and I hope it's of use.